Zoom recording. Okay, now let's officially kick off. Hello. Welcome to the Presto Foundation August 14th, 2024 virtual meetup. Good morning, good afternoon, good evening. I think we have people dialing in from across the world. So really excited. We took a little bit of a hiatus from our virtual meetups, but we're back. And in fact, we have 2 this month, which is really exciting. So welcome. We are looking forward to a really great session today on Prometheus and Presto C++ and metrics. And I will introduce the speakers here in a second. But before I do that, just a few, let's see if I can change my slides. Can I? Give me a sec. Sorry. Okay. Let me come out of this. I'm just going to do it like this. So sorry for the change here. But anyways, a few upcoming virtual events. One is we do have a virtual hands-on lab, which is tomorrow. It's at 10 a.m. Pacific time. This is all about building an open data lakehouse with Presto and Apache Iceberg. So please register for that. It's free for the community. This is our 3rd workshop in our hands-on series. And our goal is to get as many people up and running with Presto in a very simple way, just so that you can kind of get hands-on and see how it works. And so this is a third workshop in our series, and we'll do another series in the next few months or so, but please register if you haven't done so. And then, like I just mentioned, we have another meetup at the end of this month, Wednesday, August 28th, and this will be Tim, our TSC chair, sharing more about Presto Sidecar, which is all about the disaggregation of the Presto coordinator. He'll be diving into those details architecturally and technically. So please join a meetup group near you. We post them in all our virtual events and all of our meetups. And you can get all the details through the meetup group. All right, so with that, I am excited to introduce our 2 speakers today. We have Deepak Majeti and Karteek Murthy, both from IBM, both software engineers here, who have been working very hard on Presto C++. And today they're going to be talking about runtime metrics with Prometheus. We also have a special guest, Jay Narali from Uber. I think he's going to be joining us here in a bit, and he's going to talk a little bit more about how they're actually doing this at Uber, which is going to be awesome. All right, without further ado, Deepak, Karteek, I'm going to pass it off to you. So let me stop my share and go ahead, please. Welcome, introduce yourselves and take it away.
Thanks, Ali. Hi, I'm Karthik. I'll be presenting today's talk. Let me share my screen. Is able to see my screen?
Presto CPP worker stats, yes.
Yeah. Let me just start slideshow. Right. Yeah. Thanks again, Ali. Yeah, I'll be presenting along with Deepak today's talk, the Presto CPP worker stats. Today's objective is going to be to introduce Presto capabilities, reporting worker metrics, and the Presto CPP API to capture these metrics. Also share our implementation of implementing this API and how we integrate with Prometheus Time Series DB. So to begin with a simple background, here is a general Presto architecture. We have a coordinator and Presto workers. In this case, it's a C++ worker. So Presto C++ is a HTTP server and implements the Presto worker control plane and data plane REST APIs. It wraps Velox library and allows integrating with Presto ecosystem. It converts the incoming query from the coordinator into Velox query plans. So it's a very thin wrapper. That's its objective. Following that, like I said, most of the operators are implemented in Velox, and there are many events, operator events triggered during the lifetime of the query. All the operators running over worker will have an impact on the worker as well. So you would like to track this operator events as well as the worker events. The first dimension of looking at these events is operator stats. So this is available in Presto Coordinator through Presto UI, and the Presto CPP implements the required REST API to fetch these metrics. In this specific example, we have a table scan operator and its related metrics. And this is very specific to this operator. And this allows us to measure its performance. Similarly, to measure the impact on the worker, we have something called worker stats exposed by Presto CPP. And these stats can be used to measure CPU, the memory, the cache utilization, the SSD cache utilization, etc. It gives us an insight whether we are fully utilizing our worker to its best extent. Um, and coming to the interface, the Velox exposes base stats reporter class interface. This interface is used to define and record a metric. So if if this is what we're going to implement, if you want to capture the metrics emitting by the Presto server, uh, there are two set of macros defined. So all the base stats reporter methods are wrapped in a C++ macro. The first macro is to define the metric itself. It takes two parameters. It's called define metric. It has a key and a stat type. The key tells us the name of the metric. The stat type gives us a hint how this metric was captured and how we should be maintaining this metric. We have a corresponding one for defined histogram. I'll be visiting this shortly. The second set of macros are record metric value, which takes in the metric name and the value to be recorded against the metric name. We have an example which I'd like to walk through, which we recently added. Um, yeah, here is a PR that we recently added to add a new metric. The metric is called the total number of bytes and the total number of task bytes processed on a single worker. To start with, you just define the metric name. In this case, is Presto CPP, num tasks bytes processed. The second step is to define the metric. You pass in the name and you also specify the stat type. In this case, it's average type. The third step is to record the metric value. Now, this is where we emit the metric. And in this case, the metric name and value. The value is coming from the task manager. And we've exposed a method to get the metric. And in Task Manager, if you look at the method, what it's trying to do, it actually has a map of tasks. It's iterating over all the tasks and counting the total processed input data size in bytes and returning the total. So this is one way to expose the metric and record it. Back to slides. So since this we can also the first way to record the metric is there are two components, periodic task manager and periodic stats manager in Presto Simo, and they spawn background jobs which periodically capture the metrics and report it to the uh, base stats reporter through base stats reporter interface. And the second option is record the metric at the time of the event. Most of the count types are recorded this way. If you look at this example, we have the HTTP request error. So we record this metric as and when the event occurs, unlike periodically recording in background in case of periodic task manager or stats reporter. So like I previously mentioned, the stat types, we'll go through each and one stat types defined by Presto CPP. Like I said, this is just a hint how to capture and maintain it. The very first stat type we have is a counter. It represents a metric which grows with time and only resets on application restart. The most common examples are total number of HTTP requests that the worker has seen so far, the number of HTTP request errors. And here we have a snapshot. This snapshot is from our Grafana dashboard. I have an example for Velox exchange data count. This is total number of requests that the exchange client saw during the lifetime of a query or over a period of time. And as you can see, it's continuously increasing. And we have two lines representing each worker on the cluster. We have two worker node cluster. The second stat type is the sum. This is a slightly tricky one. It almost seems like a counter, but it's slightly different. Now, in sum, we track the cumulative sum of the inserted values over a period of time. So the Presto CPP reports the change in the cumulative sum since the last time it was recorded. So I found this nice illustration on OpenTelemetry documentation. OpenTelemetry is another time series DB, and here we can see there's a timeline starting from 0, and there are regular events that are occurring. And these events could be the event themselves, we're counting the event, or it could be some specific value like total bytes, or it could be time as well. And we are capturing the number of events that are happening in 1 second interval, let's say. And we are reporting this total number of events that happened 1 second over a period of time. There's one way of reporting, uh, but in fact, what we maintain internally is the cumulative sum. Like in second illustration, in first second, we have 3 events. In second, we have 1 event, and the total events are 4. So this is what we're maintaining internally, but the time of reporting, we take this 4 and subtract it from the previous recorded value 3, and we report 1, 4 minus 1, 4 minus 3 is 1. So this is the sum type. Then we have an example here. Like I said, we have the cumulative sum, the new cumulative sum, and the previous recorded value delta. This example is from Velox. It's cache cumulative new entries. We are counting number of new entries in the async data cache, and we are reporting the delta of from the cumulative sum. That's why we see a up and down graph, unlike a counter which continuously grows. Now the next type is the average metrics, average type. So this is pretty straightforward. It's the metrics that grow or decay with time. The most popular examples are CPU utilization, memory utilization, and as you can see, there's an underlying data which continuously changing, and we sample the data and we report what we sampled instantaneously, and it need not totally represent it. That's why it's an average of the actual state of the system. There's a fourth type called rate, which tracks the sum of the inserted values per second. The definition is straightforward, but we don't have any references in Presto CPP currently for this stat type. We have an example here. This is the same example that I walked through in the PR. And like you can see, we have 2 graph lines, one for the worker, another for worker 2. We are tracking the total bytes processed by all the tasks on a given worker. This is the fifth type, histogram. Histogram tracks the summary of an event over a period of time. So histogram has buckets, which are ranges, and we are counting the total number of times we saw a value in that range. In this example, this is a driver queue time. So the x-axis is the time, and 0 to 1,000 represents the milliseconds, 1,000 milliseconds, up to 1,000 milliseconds. How many events did we see? Um, Here we've seen 20 events from 0 to 500, and 500,000 we have seen probably 2 events, and 1,000 to 1,500 we have seen over 20 events. So we're just counting the number of events that occurred in a given metric range. Uh, and I'll talk about the define histogram metric API. So the first parameter is the metric name. The second parameter is a bucket range. And the third parameter is the min-max value. So given these 3, we can compute the total number of buckets, which is 10,000 minus 0 over 500, which gives us 20 buckets. That's why we see the x-axis starts from 0 to 1,000. And the remaining set of parameters is the percentiles to compute. So depending on this, the way we maintain the histogram in memory gets determined. And I don't have a graph for showing the percentiles, but yeah, this is specifies what percentile should be maintained from the given input data. It's 50th, 90th, 19th, 100th percentile in this case. So So far, I've introduced the Presto CPP, how it defines stat types and how it records them. We'll from now on talk about our implementation, which is based on Prometheus. We implement the base stats reporter. So all the record metrics and define metrics currently are dummy. If you want to actually capture them, we need to implement the base stats reporter interface. And our implementation is based on Prometheus. Um, Prometheus is a time series DB. So time series DBs are specialized to store time series events. And so time series events are very predictable. The time is always increasing and the values are mostly numerical values. So given all the nature of data, the time series events are optimized for storing the time series events and also querying them. Prometheus is one such time series database. The reason we chose Prometheus for its data format, which is sort of a standard for reporting metrics. Many other time series DBs like Influx, OpenTelemetry as well are able to ingest Prometheus data format. And another advantage we saw was Prometheus CPP library. Thanks to Jay from Uber, he introduced this to us. This library supports writing in Prometheus data format, and it has the data structures and required uh, interfaces for us to record the values and maintain it. So it greatly simplified us from not writing custom histograms. Um, Actually, maintaining count some average stat types is pretty straightforward, but histograms are a bit complicated because we need to compute the percentiles over a history of data. And this grid, using the Prometheus CPP library, greatly simplified that. And third, and another reason was we were able to map all the metric types to corresponding Prometheus metric types. So even time series DBs define their own metric types. In Prometheus, we call count, gauge, histograms, and summaries. And the corresponding ones in Presto CPP are count. And if you see, we are categorizing some average rate as gauge itself because they sort of report a value that grows and decays with time. Though sum is a cumulative sum that we maintain internally, but at the time of reporting, we report the delta. And histograms are, yeah, like we defined. And summaries, there's something called summaries which are different from histograms. This is for maintaining the quantiles, the 50th and 90th percentile. To compute them, we have a separate category in Prometheus. Uh, I'll talk about the data format here. So it's a simple text format. It has a comment which starts with a hashtag and which specifies the Presto, in this the key name, the metric name, followed by the type of metric it is. And the second line is the metric value itself. It starts with the metric name, followed by a list of labels. The label in this case are cluster and the worker. So these labels can be used on the database end, on the database client end to filter the metrics. And the third value is the metric value itself. If you notice, we don't have a timestamp here. The timestamp gets assigned when we ingest into time series DB. There's also an option to give us timestamp along with the value, the timestamp at which it was recorded. But that's normally not encouraged in Prometheus time series DB. Um, and it prefers to add its own timestamp. And now coming to the integration. So we've seen so far how to capture the metrics, collect the metrics by implementing the stats reporter interface. After collecting the metrics, we need to push it somewhere, and we decided to push it in a time series DB. Uh, it actually push or a pull model. There are two ways to do it, and the typical implementation is you have a stats reporter and the data that we've collected from the Presto server gets moved to an exporter, which is a sidecar process and within living in the same container as the worker. And this is eventually either it's pushed to the time series DB from here or the time series DB pulls from this exporter. The intention is to isolate the worker from interacting with the time series DB. And most of the times, the sidecar has more responsibility other than just capturing the metrics. It could be also tracking the logs. It could be also checking the health of the worker. But we didn't go with this approach of having a sidecar. We sort of simplified it and made the Presto server itself as an exporter. Because to begin with, we didn't have a sidecar and we didn't find any additional, we didn't want to introduce additional complexity into our design for deployment. So we just kept it at expose a REST API and V1 info metrics so that we can get the metrics directly from the Presto server. So when the time series DB can be configured to pull metrics from the worker itself. And again, not necessarily attached by time series DB. It can again be simplified to a exporter. Um, but in our case, the time series DB pulls directly from the Presto server, and the Prometheus stats reporter, which would have collected the metrics, we've exposed an API within it, and that API, when called to get the metrics, it formats the metrics in Prometheus data format and returns it. So yeah, here are the reasons why we chose Prometheus CPP as exporter. First of all, the metrics have very low memory footprint, approximately 8 KB of memory for 138 metrics, the total number of metrics that we have. And that's why I decided to store everything in memory. It doesn't have much impact on the worker itself. And second thing, we are, most of the metrics are reported by the task manager and stats reporter, which are daemon tasks that record the metrics. Approximately 60 odd metrics are reported by them. So this itself sort of works as a proxy. So we are not really interfering with the query path. Although there are metrics which are getting updated in the query path, but it doesn't really, because it's just incrementing a counter, it doesn't really take that long, doesn't really impact the query itself. On other hand, we have background tasks which are incrementing the counters and updating the metrics, which are out of query path. So which sort of made sense for us to not to have another sidecar and isolate the metrics, because it's not really having much impact on the worker. And of course, yeah, it simplifies deployment and no need to spin up another container or its memory and compute sharing. If you spin up another container and that has to share the resources with the worker, we didn't want that to happen. So we just expose the metrics through the worker itself. So going on to the next slide is setting up the Prometheus stats reporter. So we have got 3 steps. The first step is to install the Prometheus CPP. If this is, I'm walking you through if you want to build and test out locally, how to do it, or if you want your Docker builds to have steps to enable it. The first step is pre-build step is to, we have setup scripts which are triggered to set up the Presto CPP worker environment for building the build environment for Presto CPP. The one of the scripts is adapter scripts, and in the script we can specifically install Prometheus CPP library, the library that we use in our implementation to hold the metrics. Second step, at build time, we need to tell CMake and make system that, hey, we need to also build a Prometheus folder which has been added with our implementation. So this flag tells that, okay, we include Prometheus folder in the related test files. The third config is runtime config, which is runtime metrics collection enabled. There's nothing to do with Prometheus per se. It's a generic generic config to enable Prometheus and any other metric collection. Today, since Prometheus is the only implementation available in open source, so the previous 2 steps are prerequisites. If you just said this, there's no action as of now. And okay, yeah, that was the end of my presentation. And I have a quick demo. I can show our dashboards. I just spun up a cluster and we can take a look at dashboard on Grafana. So
Karthik,
here's the first.
maybe we can ask for quick questions before
Oh yeah, I thought after
the
this
demo
ask
quickly.
questions. We can go for questions now.
Yeah, and then we can do a demo. Maybe we can answer some of them in the demo.
Yeah, yeah.
Are there any questions
So,
in the?
yeah, if there are any questions, either put them in the chat or feel free to go off mute if you're on Zoom and ask. Give it a few seconds here. I don't see any in the chat. Any on LinkedIn? Nope. All right, I think we can keep going.
Awesome.
Awesome. All right. This is the name of the cluster, and it has two workers. Actually, I mean, this thanks to Ethan and Ling Song and Ing who helped us set up this dashboards. They got a lot of work to get this up and running. So Ethan, Ing, and Ling Song are from IBM, and like you can see there are some stats which are already available through the coordinator and also the container. Uh, um, the Docker container itself emits some statistics which are capturing. And these are some stats which are coming from Presto C, which I already included in our example, the cache cumulative new entries, the cache cumulative hit entries, how many times we hit the cache. And there we also have some SST related statistics here, which right now we're not using it. Ran a query, so we have some activity in the workers. And yeah, this is it. And I also want to show how you can get directly from the worker the statistics. So here we have, I've logged into the worker node in a container, and you can issue a curl command. I hope this works. Yeah. Oh, yeah. So this is the cluster that I just demoed in Grafana dashboard. And this is the API that if you do a HTTP against the worker node and this REST API, we can get all the metrics currently in memory in Prometheus data format. It has the metric name, the cluster name, and the worker ID. And this in this specific case, this is a summary metric which I mentioned, which has quantiles in it. And we also have a lot of histograms. So we have a histogram here. It's pretty long with a lot of buckets. So Velox exchange data says histogram, a lot of buckets, and yeah, this is it. Any questions on this? Mhm.
I think we're good. If I don't know if this is it, Karteek, if it is, we can, I think Jay's on if Jay wants to share more of.
Sure, sure. Yeah,
Yeah, yeah, sure. Thanks for the presentation. Thanks for the presentation, Karthik. So, yeah, so at Uber, we have a similar time series DB called M3, and I think it's not open source, but it also supports push-pull model, and it has a stat collector as a service which can pull metrics from services if they are in Prometheus format, right? So worker metrics were obviously a blocker for us to go to Velox production, right? Since we need observability in a production service. And yeah, and we've been using a similar setup with the library since the beginning. So yeah, and we didn't see any production issues as of now. We just started onboarding traffic, like around 5 to 10% of press remote traffic, but we haven't seen any production issues as of now. Yeah, the so our framework at Uber is similar. So instead, in the slides, as Karthik showed, the Presto server was pushing the metric, was making metrics available for pull at an endpoint. So instead of that, we just used the library's own exposure. So the library provides its own exposure, so which becomes like a subthread in Presto, right? And which has its own HTTP server. So we we just did that since it was easier at that time. And and yeah, I think the next steps for this would be to isolate resources if we can for the exposure, since we don't know if it can, consume more I think Karthik recently discovered a high cardinality metric issue, right, which was causing query slowness. So, uh, so I think, yeah, the next steps would be to fix something like that and maybe improve observability around metric collection. So yeah, and on the use, so how we use metrics, I think currently we haven't used that much. We did use monitor some memory metrics when we switched to some new memory allocator in Presto. So we used at that time. Also, I think since we are now starting exploring the async data cache and spilling, I think metrics would be crucial over there. So yeah, that's what I wanted to share. Thank you.
Thanks, Jay.
Thank you.
Yeah, that's it from my end as well. And yeah, thanks to Deepak and Jay from Uber for giving design inputs and code reviews. And thanks to Amit Datta from Meta for sharing their knowledge on this topic. And also thanks to Ali. We really appreciate you for coordinating the event and bringing us all together.
Great. Awesome. Thank you so much. I'm going to drop in the chat some of the upcoming Presto community events we have. But Deepak, Karteek, thank you so much. I think it's really exciting, all the work going into Presto C++. There's so much. So we have been writing blogs. There's a bunch of sessions for folks who want to get a little deeper in what's going on with the native worker group, native worker work that's going on. These two from IBM, along with Jay, are very involved in the project. So they are subject matter experts. If you do have questions, please join us in the Slack channel, the Presto community Slack channel, which I dropped the link there as well. This is where the Presto engineers hang out. And it's a great place to connect and to ask your questions. And if you're new to Presto, a good way to get started is to start there. All right, so with that, I hope to see many of you tomorrow at our hands-on lab. Again, that's building an open lakehouse with Presto and Iceberg. That's happening tomorrow. And then in 2 weeks, we have our next meetup right here, same place, same time. We hope to see you there as well. Okay, with that, thank you again to our presenters. It was great, and we look forward to seeing you at the next one. Bye, folks.